Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to focus our attention on the Earth's rotation. It is so important for you to understand the difference between rotation and revolution, and it's really important for you to understand what characteristics we observe due to these two motions. Now I have a whole nother podcast in the series strictly focusing on the seasons and revolution. This one we're going to focus on rotation. The most important phenomena that occurs with rotation, day and night. We know that our Earth is going to rotate once every 24 hours. So if you divide 360 degrees, the degree value within a sphere, and you divide it by 24 hours, it's going to come out to be 15 degrees. So our Earth actually rotates 15 degrees for every hour that goes by. What's important about that? That's the width of longitude for every time zone. That's also the amount of hours that will change with each time zone as well. Every 15 degrees that you travel of longitude is going to be a different hour. Now, depending upon whether you travel east or west, is a different story. That'll tell you whether or not your time's going to increase or decrease. But our time zones are based upon the rotation of our planet. Now, our Earth is always going to be half lit and half dark. You'll notice that the Earth is going to rotate in a counterclockwise direction. In this case, the sun is on the left-hand side, so the left side of the Earth is going to be illuminated. Now, the gradual change of darkness or the gradual change of daylight is what we call dawn and dusk. So it's just not going to happen immediately. It's a gradual darkening or a gradual lightening of the Earth. That's where dawn and dusk come into play. Now, the characteristics that you need to know about rotation include we travel west to east with our rotation. We rotate counterclockwise, so essentially we rotate west to east. We rotate 15 degrees per hour in a counterclockwise direction, which will cause our stars, including our sun, to rise in the east and set in the west. Now, our stars rising and setting is what we call apparent motion. The stars physically don't move in relation to us. They're just too far away for us to locate any movement. They appear fixed in the nighttime sky. So including our sun, things will rise in the east and set in the west because we're the ones that are moving. Remember, the geocentric model that Ptolemy created said that we were the center of everything because the stars and the sun move around us. Well, it was later discovered by Copernicus that was not true. We were the ones that were moving. So your stars are essentially fixed. So it gives you a little bit of an optical illusion that with these stars, including our sun, rising in the east and setting in the west, it's caused by our rotation. Now, we can figure this out by actually photographing our stars. We can literally take our stars and take time-lapse photography and take pictures of the stars, creating what are called star trails. And what this does, it takes photographs of the apparent motion of our stars and shows us how the stars appear to move through the nighttime sky. Remember, it's us that's moving, not the stars. So looking north, your stars will make circles around Polaris. Looking east, they'll be rising upward. Looking south, they'll make small horizontal paths across the sky. And looking west, they'll be setting in a downward motion. So those are your star trails. Know the direction of north because that's where Polaris is. That's going to be the most important direction. Here's the apparent motion of our sun. This is during just a random day throughout the year. And you can notice that the sun's path throughout the sky is actually caused by our rotation. The sun physically doesn't move across the sky. We're the ones that are rotating. Now, there's a couple pieces of evidence that support the idea that the Earth rotates. One's called the Coriolis effect, and the other one's called the Foucault pendulum. Now, the Coriolis effect's important. It was named after Gaspard Coriolis. He basically came up with the idea that anything fluid, our ocean currents and our wind currents, will have some sort of deflection due to our rotation. In the northern hemisphere, things get deflected to the right. In the southern hemisphere, things get deflected to our left. Now, anytime you let out a drain in the toilet, it let out a drain in the sink or in the tub, that's too small of a quantity of water to get any kind of direction due to the Coriolis effect. When you're dealing with water or you're dealing with air, you're dealing with massive wind currents in the upper atmosphere or massive ocean currents in the northern or southern hemisphere. So in the northern hemisphere, deflection to the right, southern hemisphere, deflection to the left. It's an idea that the Earth rotates on its axis. So you can see the little guy in position A and the little guy in position B. I've kind of labeled his right and left. So you can see in the northern hemisphere, things get deflected to the person's right behind the cannon, And in the southern hemisphere, you can see the little man, everything gets deflected to the person's left when you're facing the southern hemisphere. So very important to have an idea in terms of the direction of deflection. The Foucault pendulum is important here because it also provides evidence that the Earth rotates as well. The pendulum was swinging in a north-south direction, and as the Earth rotated underneath it, the pendulum would swing back and forth. It would knock over a series of pegs. Based upon the spacing of your pegs, usually the pendulum will knock over a peg in the foreswing and on the backswing. So over a series of time, over a 24-hour period, it should knock over the complete series of pegs. So something that looks a little bit like this. You see the blues, the yellows, and the reds. You'll see that the pegs opposite each other get knocked over. So you see the series of pegs. The pendulum would swing exactly north-south as the disk of pegs rotated with the planet. And again, this is an idea that the Earth rotated on its axis. Extremely important to have those ideas. So that's it for now. Good luck with the Earth's rotation.